All right, today we are diving into a brand new blueprint for artificial intelligence. And this isn't just about making AI bigger, it's about fundamentally changing how it thinks.
Have you ever noticed this weird thing with today's AI? I mean, on one hand, it can write beautiful poetry or create these mind-blowing images, a total creative genius. But then on the other hand, you can give it a simple logic puzzle that a kid could solve and it just completely faceplants. So what is going on here?
Well, it really all boils down to the difference between shallow and deep thinking. You see, most of the AI we use today runs on shallow thinking. It's kind of like a student who just crams for a test. They memorize a bunch of facts but can't really apply them in a new situation. What we really want is an AI that's more like a detective, one that connects all the clues and uses deep reasoning to actually solve the case. So this brings us to the first big idea, this paradox of shallow AI. And it turns out this shallowness isn't just some minor quirk. No, it's the root cause of some of the biggest problems we have in AI, including that infamous and frankly very frustrating issue of hallucinations.
So what exactly is a hallucination? Well, it's basically when an AI just makes stuff up. It gives you an answer that sounds totally plausible, maybe even super confident, but it's just plain wrong. This isn't just some bug. It's a fundamental source of unreliability. And it's a massive wall blocking us from using AI in really high-stakes fields like medicine or finance.
And here's the crucial point. We can't solve this by just throwing more data and more computing power at the problem. We've kind of hit a wall, an innovation bottleneck. The way forward isn't about building bigger AI. It's about building smarter, deeper, and fundamentally more trustworthy AI. We need a whole new way of thinking about how we build these things.
And that, of course, brings us to the solution. A new kind of AI framework that's been designed from the ground up to actually think, reason, and even correct itself. It's called GSAA-HRVAE. Yeah, a bit of a mouthful, I know, but the ideas behind it are incredibly powerful.
Forget that long name for just a second. This quote right here is the North Star for the entire system. It's smart, it gets better all on its own, it thinks in layers, and this is key. It has safety rules hardwired right into its core.
Now, to really get our heads around this pretty complex system, we're going to use one powerful analogy. For the rest of this explainer, I want you to think of this AI not as a bunch of code, but as a super advanced, self-organizing company.
Okay, let's just quickly tear apart that name, because each part tells you something really important about our AI company. Governed means there's actual human oversight. Self-adaptive evolutionary, that's like having a brilliant R&D department that never sleeps. Hierarchical gives it a management structure for deep understanding. And recursive, well, that's its secret weapon for cracking those really tough multi-step problems.
So, are you ready? Let's take a tour of this AI company. We're about to meet the different departments and see exactly how they work together to create a machine that might just be able to truly think.
First up, the R&D department. This is where the AI improves itself. It basically runs on a survival of the fittest model. It starts with a whole population of slightly different AI designs. Then it introduces these small, random changes. You can think of them as mutations. After that, it tests them all, really puts them through the ringer, and only the best performing, most honest models get to survive and move on to the next generation. It's literally evolution in action.
And now for the main event, the brain trust. This is how the AI thinks. And it's not just one single process. It's a team of two. First, you've got a fast, detail-oriented thinker that dives deep into the nitty-gritty of a problem. Once its ideas are stable, it kicks them up to a slow, big-picture thinker. This is the strategist. It reflects on all those details, makes a high-level decision, and then sends it back down for more refinement. This back and forth, this loop of analysis and strategy, that is deep thinking.
You know, any powerful company needs strong governance, right? Well, this AI is no different. It has a 5-level management structure. Think of it like a corporate ladder. At the very bottom, you've got the factory floor workers, just processing data. Moving up, you have departments for compliance, R&D, and strategic planning. And sitting right at the top, the Quality and Ethics Board. Their whole job is to verify integrity and, you guessed it, check for hallucinations. This whole structure makes sure the system is stable, controlled, and safe, from the top all the way down.
Now, built into this whole governance system are two critical safety policies. And the first one is just brilliant. It's an honesty policy. Instead of rewarding the AI for just spitting out any answer, this system actually rewards the model for admitting when it's not sure. And this is the real kicker right here.
Just think about how revolutionary that is for a second. Most AIs today will just guess when they're uncertain, and that's exactly where hallucinations come from. This system completely flips the script on the incentives. It's designed to be cautious, to be honest, and to tell you when it just doesn't know. That's how you build trust.
The second critical safety feature is what you can think of as the board of directors. It's a special mechanism called the modification gatekeeper, and its job is to make sure that even though the AI can learn and evolve on its own, any major high-level changes require approval from a human. The ultimate control always stays with us.
Okay, so the theory sounds amazing, right? A self-improving, honest thinking machine, but does it actually, work? Let's look at the performance and see why this whole deep thinking approach really matters.
When you put it to the test on really complex tasks like analyzing the structure of chemical compounds, the results are just dramatic. This framework learns 3 times faster than the baseline models. That means it gets to the right answer more quickly and with way less computational cost. That's a massive advantage.
And it's not a one-trick pony either. The results are impressive across the board. In text processing, it hallucinates 15% less. In that graph analysis, not only is it 3 times faster, but it's also more accurate. And maybe the most impressive thing of all, on really tough abstract reasoning puzzles, it hits 45% accuracy with a model that is tiny, just 7 million parameters. This proves the architecture isn't just powerful, it's also incredibly efficient.
So where does a technology like this take us? Well, the potential applications are pretty mind-blowing. In bioengineering, you could use its evolutionary nature to simulate incredibly complex things, like how our cells regenerate. Or, in robotics, its ability to reason deeply could finally lead to robots that can navigate our messy, unpredictable world far more effectively.
So as we wrap this up, if there's one big idea to walk away with, it's this philosophical shift. We have to move beyond this race to just build bigger and bigger AI models, and instead focus our efforts on building smarter, deeper, and above all else, more trustworthy systems.
And that leaves us with one final, and I think really important question to chew on. If we actually succeed in building an AI that can truly think, deeply, logically, and safely, what are the first problems we should point it at? What massive challenges could we finally overcome? That's something to think about.